In this part of section 3.1, we're evaluating the difference quotient. So by definition, this is the difference quotient. So our example, our function is going to be -1 minus x minus 2x squared. So to find this, I have to evaluate, similar to what we did in the previous section, just evaluating the function at x plus h and x, and then dividing all that by h. So this gets a little messy, so it helps to break it apart and do this part first, and then you can plug it back into the difference quotient. With this part is already given to us in the original, that is the original function, so we make sure we do minus that. So what I want to do to evaluate the difference function, I want to find the f of x plus h, and then find out whatever that is, and subtract what we're given up above in orange, the -1 minus x minus 2x squared, and then divide all of that by h. So I'm going to take this piece by piece. I'm going to take the blue piece first. I'll use light blue to match that highlighter. So we're looking at for f of x plus h. So f of x is, I'm going to rewrite f of x, except I'm going to leave the x's out as parentheses so I can replace them with an x plus h. So f of x is -1 minus x minus 2x squared. And instead of x, I'm going to write x plus h. And then evaluating that, I get -1. I'm going to distribute my negative to get -x minus h. And then before I can distribute that -2, I got to deal with those parentheses exponents. So I'm going to write my steps here. So right now I'm evaluating the parentheses. I can never remember how to spell parentheses. And so before I can distribute that -2, I gotta get rid of the exponent on that, so I can just distribute -2. So that is, let's see, that's a perfect square trinomial because it's a perfect square. So x squared plus 2xh plus h squared. And if you're ever in doubt, you can always write it out twice and just FOIL it. And then my next step, I'm going to continue evaluating the parentheses by distributing this -2 to that parenthesis. So that gives me a -2x squared minus 4xh plus h squared. So my parentheses are gone now. I'll copy down the part that didn't change. Okay. I messed up here. That should be a 2. Sorry. Negative. Sorry. -2 times h squared is a -2h squared. There we go. That's better. All right. So I don't have any like terms here, so I really can't simplify this any further. This part, this thing that we just found then is the simplest form of this piece. So I'm just going to copy down my difference quotient down here. That's my difference quotient. I'm going to copy that down and fill in the gaps. So we just found that blue part, and the orange part is at the top. That's what's been given to us. So we have the blue part is -1 minus x minus h minus 2x squared minus 4xh minus 2h squared. All of that, and then we have the minus sign, and then we have the orange part, which is the just f of x, -1 minus x minus 2x squared. All of that over the h. So I need to simplify that numerator to see what I can cancel with an h. I'm going to go with red. So, what should I do here? So I want to get these things so I can combine like terms. But before I can do that, I need to distribute this negative to get rid of those all the brackets. I don't need to do anything to the first bracket, the blue, because there's no negative sign in front. So I'll just rewrite it. And I get -1 minus x minus h minus 2x squared minus 4xh minus 2h squared. And now I got to distribute that negative into the orange. So I get negative times a -1 is a +1. Negative times negative x is positive x. And negative times -2x squared gives me a positive 2x squared. All over h. All right, let's see if we can combine some like terms here. So I'm trying to simplify that numerator all over h. So simplifying that numerator, what can I combine here? Let's see. Well, I have a minus 2x squared and a plus 2x squared. So my x squared terms will actually cancel. And then going to my h squared terms, I only have one of those. So that's the -2, I'll use a different color. Minus 2h squared, so I'll keep that right here. All right, and then going on to my linear terms, let's see, I have a minus x right here. That's my only, oh, I have another x over here. I have a plus x over here. Those will cancel, negative x and plus x, those become 0. And then going on to my h term, I have a negative h. I don't have any one to combine him with, so I'll do negative h here. And then my I have for constants, I have a -1 and a +1. Those will cancel. -1, +1. And then the only thing I have left is the blue -4xh. So I'll write that. Okay, now I can deal with that h that's in the denominator. And to deal with that, I have to remember that when I have a plus or minus in the numerator or the denominator, I can only cancel things out if I have something in every term. So to remember that, I like to think about that divide h as it being here, and here, and here. That's the same thing as having one big H under that entire 3-term piece. There has to be the common factor in all the terms. So if I decompose it like that, I can remember I got to take it out of every term. So taking the H out of here, I'm left with a -2H, and taking the H out of here, I'm left with a -1. Whoops, the negative is still there. And taking the H out of here, I'm left with a -4x. So that leaves me with my final answer, which is -2h minus 1 minus 4x.